Good morning. Again, my name is Kari Metcalf. Thank you for giving me a chance to talk a little bit about how we've been managing our GIS in a number of offshore wind projects. And a brief background on myself. If you want a title, I am the GIS coordinator for the Portland, Maine Tetra Tech office, but I am local. And for the last 8 years, I have worked on a number of renewable energy projects, really across the country, solar and wind, primarily in New England, a number of wind projects in the Midwest, and then solar as well in the western states, California and Colorado. And then for the last 4 years, we've been working a lot on some offshore wind projects. The East Coast was the first area to offer leases. So I guess we need a description of where offshore and terrestrial fall. So for the last 4 years, we've done a number of projects on the East Coast, and those have been really exciting to work on because they're such large projects. And aside from the kind of the really interesting renewable energy aspect, they generate a large amount of data. They're really very new. And so we've had kind of an exciting chance to use a number of different GIS applications to manage data and just kind of help move these projects along. So this presentation, I'll give a quick overview of what offshore wind planning and project and the process is, and then go through a couple of the GIS applications we actually use in the projects. So, offshore wind at 100 miles an hour. The gray areas on the map are leases or planning areas, and so these come up periodically for lease to an energy company. Some of these will never, actually be leased, but they are a planning area. Occasionally, they're revised by BOEM. The pink ones are either actively leased or actively under construction. East Coast, again, that was the first area that was offered for lease. So those projects are further along, and some of them are under construction. A couple of the ones they're off of kind of Central California, those were auctioned off in Christmas. So they're still in the planning stages. And then the most recent one that was auctioned last month was the first one in the Gulf of Mexico, right off of Louisiana there. And so my role has been in a lot of the planning stages. And so this is just a kind of an overview of what Tetra Tech has been involved in as far as each leased area. And so it's hard to see on my first screenshot, but the leases are sort of subsets of larger planning areas, and different companies will bid and win the rights to develop the areas. And so again, I have been involved in a lot of the planning stages, and I am not a marine biologist or any kind of electrical engineer. I come to GIS through wetland science. So any water that's over about 3 feet is not really my natural habitat. But once the engineers decide on an offshore route, I'm involved in the routing once we reach the land, landing sites, critical issues analysis, constraints analysis once they have picked a landing site and a few routing areas of interest. And so background on how a company will come through the lease process. Company submits its qualifications to even bid on a lease site to BOEM, and when they're approved, the bids roll in periodically as each lease area is sort of approved for final bidding. And if a company wins, so they begin the preliminary phase. The first big step is to prepare the site assessment plan. So this is just saying, we're going to go out and we're going to review, do the actual on the ground surveys or on the water surveys for the planning. And that's up to a year. And then when that's approved by BOEM, then we move into the construction and operations planning stage. And that stage alone can take 1 to 5 years. planning. And then again, there are actual field surveys going on for that. And then once the COP is approved, then you can move into the actual building and construction and the operations term. So again, just personally, where I tend to get involved is once we land, pick a landing site or two. We're doing the issues analysis on constraints. We're running through a number of routing alternatives to different substations. And then just as a GIS analyst, managing all of the data coming in from all of the different surveys. People doing the actual work. I don't get to leave the office, but here's people actually in the field doing this kind of stuff. So the first tool that we use for managing the process is Model Builder and Task. And this came about because, well, it's been a similar process with other renewable projects, with a solar site or with any kind of wind site, there's any number of revisions to the actual site. But those were more pixel pushing. We're going to rearrange a turbine, we're going to rearrange the solar layout. But suddenly with the linear routing involved in the offshore wind, we were doing the same process repeatedly, and each time there was a revision to the potential route, we had to rerun the same analysis. And it became very obvious very quickly that Model Builder was the way to go for this. And I'm going to skip to my main point, which is we chose Model Builder over any kind of scripting because it's easy to use. It's easy to set up, it's easy to rearrange. And when you have a large number of teams with a large number of skills doing the constraints analysis and looking at the data, Model Builder was just the fastest way to kind of preserve this workflow. And so, we'd pick a potential route, and then we have to rearrange it a little bit, and we have to pick a different landing site, or we have to scratch the route entirely and choose a new route. Model Builder was the obvious choice for selecting, just putting all your work in there. If you're going to have to run it multiple times, there's no point in building it from scratch each time. One of the things that kind of just excited me about doing the offshore projects was the data source. It's for the most part, it's a regional data set. It didn't cross state lines, so I could throw it all into a model and not have to worry about it. I can run that for the entire East Coast, and regardless of how many offshore routes we've chosen. Over the last 4 years, a whole lot of data has been moved into online resources, which was another kind of time-saving step. We can drag the REST services directly into the model and not have to worry about data downloading or making sure we have the most up-to-date data. We can pull in those URLs directly into the model, and that was another step for saving some time. And again, we went with model because it's just so much faster to build, and you can make it as complicated as you want, or you can make it as simple and obvious a step through process as needed for the team. And so that's been kind of exciting. And so it creates just a work log of your process. Some cons, I mean, no program is the best, but some of the terrestrial resources, if we're doing a constraints analysis for the terrestrial routes on land, those inevitably cross state lines. So you still have to have multiple data sources for that. So let's say we're trying to match the wetlands from the Massachusetts border to the wetlands in the Connecticut side. So we still have to finagle that a little bit. Some of the nearshore resources, archaeology resources, eelgrass, those still kind of are state driven, and so we have to have an individual process for some of those, and inevitably URLs break and change. So models aren't completely hands-free, but they were the obvious choice for creating a workflow that many teams could adapt to quickly. The other one that has been super helpful is tasks. And this is a new feature to Pro, I think, although Pro itself isn't really new. It's been around for several years now. But this was also an interesting choice in creating a workflow and a work log for our projects. And it's kind of similar to Model Builder in that it preserves your steps as you go through it. It's a little different. It does not preserve the input, your inputs. It doesn't preserve your sources. It doesn't preserve what it is you're doing the geoprocessing on. And then in some cases that's great. We don't need that. This example kind of a noise analysis that we run routinely on some substations or potential substation locations. And so you can quickly pass that between teams. It can stay with the document, or you can just make sure it moves to a new team as needed. And I initially, the task is interesting because you can record your steps as you do them. And initially I was kind of put off by that because, well, what if I make a mistake? It's very editable. I should have realized that. But it's very editable to go in there and correct anything. And then you can use it sort of as just literally just looking at the steps and running it yourself, or it'll walk you through each step. Again, we have a number of teams working on a number of different aspects of each of these projects. So being able to pass this off has been very helpful. Just for example, on here, I have number 4 properties. That was just literally me opening the properties tab. So something like that can be removed as needed. So that's been critical in preserving the process of what we're doing, because when you're going at 500 miles an hour to correct and address changes to a route, it's we don't need to rebuild the process each time. So let's see, people with jobs that are a lot more interesting than my own go out and collect a number of the field resources. We'll collect data for these different surveys. And then once they bring that in, we have the task of kind of tracking that data and sharing it. And for sharing, have the usual suite of Esri options. We have gone with Portal for a number of reasons. Portal is very similar to the kind of traditional Esri online environment, but Portal is hosted through your agency's network rather than through the Esri online network. And so we do this to enable sharing both internally within Tetra Tech and then within any of the collaborators on the projects. But it's basically your usual ArcGIS online kind of environment, which enables us to do the fun stuff, which is making some maps. And so we take all this data and we stuff it into a map. And this is really very client driven and need driven per each effort. We have collaborations with the biologists, we have collaborations with the construction and the engineers, and they all need a different thing. This is an example of the Central Virginia offshore wind. Was one of the first ones, and they're one of the first ones going into construction. And so what we needed to be able to communicate the plans directly with BOEM. We needed to communicate it directly to U.S. Fish and Wildlife Service. So we set up internal maps to have the data shared securely with them. And it's all driven by a user login tied to an email. So we could control who we were sharing it with. And then it was editable based on their needs, based on client feedback. We could update, we could control the data as it changed, as this data is inclined to change every few minutes. And then the other fun part was making public facing maps. So we can host that through, again, either just ArcGIS online or Portal environment. I don't know if I need to, if I click on the live link, is it going to blow everything up, or I have to go the other way? I don't know if this audience really needs a walkthrough of a web map, but so that was the other thing, is that we could take this and throw it onto any number of public resources as needed. And so this is an example of a web map we host for the New York State Energy Research Development Association. We take the data, we put it online, we can host it. Ooh, I am going backwards. Thing is very difficult for me. Oh, right. Okay. Anyway, not sharing the PowerPoint. That's fine.
Yeah.
It's a web map. Most of you are probably familiar with the web map. But then we can, that's the fun part, is the design of the web maps, dashboards, any number of the Esri Experience Builder kind of gradient of mapping available for that. And so again, that's all. It can come from a single source of data that we host, and we don't have to worry about versioning. We can track it all. Now, what am I sharing? It's going to work. Oh. So we're going on 90 miles an hour here, but straying out of pure GIS a little bit and into document management. So to prepare the staffs or the COPs or these documents that are going back to BOEM, they produce 100 maps, hundreds of maps. So that alone becomes a kind of a management issue of how to track the deliverables going to the to BOEM. And so this is just a kind of an overview of there may be 50 maps within the executive summary alone, not to mention however many maps are going into each one of these appendices. And so the GIS team kind of worked with the tech editing team to come up with a standard plan of exporting maps to a single location, and then tech editing and pull in those maps without having serious versioning issues across 200 maps. I won't pull up the live link here, but this is just an example of a few of the maps that we would kind of have to manage. And so if any of the line work changes, if any of the text on the actual map changes, tech editing kind of helped us create a workflow whereby we put it all in a folder, basically appendice driven, which is sort of how they were driving their changes. And they gave us a series of best management practices to make it, to manage the number of maps, some of which were a template that fit like an 8.5 by 11. Kind of just traditionally, we had always worked in a slightly larger format, and tech editing says, no, this isn't going to fly for us. Some of it's driven by the BOEM needs as well. And so a lot of the magic kind of boils down to what I have on here, which is the link function within the actual Word document. And so that kind of links it directly to a map. And so GIS can get in there and make any changes they need to the maps, dump it right back into the same spot. And tech editing doesn't have to worry about tracking these maps and making sure that each individual change has been pulled through all 100, 200 different map figures. So that was a big time save, and it's a hard fought lesson to kind of streamline that process. So that's again, that's the process at 200 miles an hour. A couple of interesting things at the Esri user conference this summer. They were promoting a GIS and renewables group, trying to kind of just pull together companies, resources involved in renewable energy, and develop tools that are useful for them. And because we are giving this presentation within inside of one of the world's largest lakes, I know a lot of local interest in is offshore wind ever going to come to the Great Lakes? Not my area of expertise, honestly, but I do know, so like NYSERDA has done some research on the Great Lakes near the New York, Erie, I believe, has a test project going in. And as far as I know, there's nothing going on in Superior, but I'm sure somebody is interested in it. So these are just a couple of resources that if you're interested in looking at that kind of information, you could look into. And any questions? Questions in person? Yeah.
Can you comment on the challenges of data in the ocean? Because it's, I mean, it's like subsurface as well as the surface, I guess, important aspects of the process.
Not necessarily where I'm involved. They do have the, you know, they go out and they do the sonar, they do the bathymetry. They'll get custom bathymetry for their areas of interest. And honestly, I don't process that. But once it's processed, we pull it in and manage it just basically like any other elevation data. And as far as displaying it, it's not necessarily any different. Construction teams, I'm sure, do deal with, you know, depths and stuff, but where I've been involved, it hasn't been necessarily any different than any other elevation data, just going the kind of the opposite direction than usual.
Customers, also data team as well. The processing end of it, when you have your model to go there and you crunching numbers, how do you handle or where's the storage of all of that data and access to it for your, you know, within Tetra Tech and, you know, it seems as though people are working remotely or in different locations. Is that all handled on, you know, OneDrive kind of thing, or a server that Tetra Tech has, and everybody just VPNs into it to
Until 3 months ago, it was all handled on local servers, so office base, which worked well for that. Again, I kind of mentioned we have, we'll say, roughly 3 teams kind of working on projects individually, and then recently we have moved to a single server, but basically it's kind of per office and individually stored. And so, yeah, we have been kind of trying to move to a more centralized location for the wind efforts. And with the centralized GIS server that we have now, that's an improvement. It's kind of every man for himself before that.
do you find difficulties trying to process that type of information through you know, basically online through internet services, say you're gonna do a cost analysis of your backmetric data, for example, that could be a really high resolution giant GIS data set. Is that an issue with not having the data locally in Virginia?
No, again, the teams handle that individually. So it would be, we'll say, processed locally by the team that collected it or whoever been set up to process it. And then it gets fed around as needed. So it's, I guess it's managed in the planning stage. You know, we make sure that that is not going to be an issue in disseminating the actual information once we get it. Again, just for sheer data management, we tend to keep it local and then spread it around as needed. So. Well, thank you.